The rhinoceros beetle is no heavier than a slice of bread, yet it can somehow lift a rock the weight of a MacBook Air. For reference, this is like a human bench pressing an adult rhino. Tiny creatures can perform the most extraordinary feats. Fleas can leap 150 times their body length, and mantis shrimp punch with forces over 2,500 times their body weight. Heracross is basically that on steroids because, unlike normal bugs that might be 54 grams, Heracross is a 54 kilogram behemoth. As a result, it can supposedly easily flip tanks with its horn. By the way, the largest insect that ever existed on Earth was just about as large as a bird. So, could Heracross exist? And if it could, how strong would it be? Heracross is essentially a human-sized rhinoceros beetle, standing at 1.5 meters tall and having a mass of 54 kilograms. By contrast, a Hercules beetle, a species of rhinoceros beetle known for being one of the largest insects in the world, is only around 7 centimeters and roughly 1,000th the mass of Heracross. It is tempting to conclude that since a Hercules beetle can lift 40 times its body weight, if a beetle ever grew to the height of an adult human, they could take over the world. Planet of the Apes? More like Planet of the Ants? Ants can lift even more weight relative to their body weight than beetles. Some worker ants can lift 50 times their body weight. So, why haven't huge insects the size of elephants evolved yet? The answer doesn't come from biology, but physics. According to Galileo's square-cube law, if length increases by n, area grows by n squared, but volume and weight grow by n cubed. To grow a 30-gram beetle into a 54-kilogram beast, that means n cubed equals 1,800. However, the surface area of its muscles and skeleton would only be about 150 times bigger, not 1,800 times, so its sudden weight increase would outpace its strength by a factor of 12. So instead of being able to lift 40 times its body weight, it would only be able to lift about 3 times its body weight. And that is exactly about the maximum weight a person can lift. Comically, Heracross would have to be the size of a dog because its length would be constrained to 85 centimeters due to its colossal exoskeleton. If we go the other way, starting from a 7 centimeter beetle to a 1.5 meter beast, we get n is equal to 200. First of all, this would make Heracross a massive blue whale, or about as massive as a steam train, at 240 metric tons. However, it would only be able to lift a fifth of its body weight without crumbling under gravity, which would make this Heracross a mandatory water type. This would also be realistic since a blue whale would probably be unable to support as much as 5% of its body weight on land. Beyond strength, there are metabolic and respiratory bottlenecks. We breathe through a wide windpipe that siphons air into the blood via hundreds of millions of tiny air sacs, also known as alveoli. Insects, on the other hand, breathe by absorbing oxygen directly from the air using a system of tubes. That works when your body is only a few grams, but a 54 kilogram insect wouldn't be able to supply enough oxygen to and remove enough carbon dioxide from each cell that way. Our giant beetle would effectively suffocate unless it reinvented its respiratory system. Metabolically, it would be ectothermic like other beetles. Yet, maintaining a large body of muscle demands enormous energy. This is because the square cube law states that it is more difficult for a larger animal to warm up or cool down. This is why most mammals are endothermic. It is easier to rely on food and maintain a stable body temperature than to lay motionless and vulnerable for hours, like a crocodile. Finally, the horn and exoskeleton material itself face physical limits. Heracross's horn acts as a lever. A 1 meter long horn swinging with mega horn-like force would put immense bending stress on the base. Real beetle horns are made of a chitinous composite and only yield at tens to hundreds of megapascals. If Heracross charged with even a few thousand newtons, the stress would crack the horn. Perhaps that's why some insects have elastic materials like resilin to absorb shocks. Indeed, fleas and trapjaw ants use protein springs to survive extreme forces. The froghopper's chitin thorax can store approximately 65,000 watts per kilogram of elastic power for its jump, and trapjaw ants can snap their jaws closed at over 140 miles per hour by storing up to approximately 200,000 watts per kilogram. If Heracross had resilin, would it then be able to toss 5 cosmoem at once, like the Pokédex suggests? Suppose Heracross's horn is 5 kilograms and can store as much elastic energy as a trapjaw ant? Then the power from the horn alone would be about half a gigawatt. To launch 100 times its body mass at a rate of just 2 meters per second, it would need to output about 10 kilojoules. If it flicks its horn in 0.1 seconds, it can easily accomplish this feat. As a side note, Mega Heracross would need to store elastic energy for much longer than 0.1 seconds, or have some other trick up its sleeve to be able to launch 500 times its body weight. If you'd like to see me analyze Mega Heracross, like this video and subscribe so you don't miss it. Horned beetles also exert high forces during battles for mates, and thus there may have been natural selection for the ability to generate large forces economically. So perhaps Heracross evolved in a similar niche, a buzzing jungle colosseum where only the strongest win females. As a bug/fighting type, its biology hints at territoriality and brawling. However, at 54 kilograms, Heracross would be taller and heavier than any insect that ever lived, and that includes the ancient giants. During the Carboniferous era 300 million years ago, dragonfly relatives called griffinflies reached about 70 centimeter wingspans in atmospheres with about 35% oxygen. For reference, we currently breathe air with about 20% oxygen. Nevertheless, their bodies were still only a few centimeters thick. No known insect even came close to 1.5 meters. Higher oxygen helped them grow, but even prehistoric oxygen only got rid of some breathing constraints. In fact, When birds arrived about 150 billion years ago, even as oxygen levels rose, insect size fell because smaller creatures were more maneuverable and made for better predators. In short, there is no selective pressure to evolve bigger bugs. It's a good thing something like Heracross doesn't exist in real life because the devastation it could cause would be epic. After all, one Heracross could overwhelm 100 people just by charging with its horn. Speaking of horns, let's zoom in on what used to be its signature move, Mega Horn. Mega Horn is like a ramming attack, a 54 kilogram beetle moving at, let's say, 10 meters per second, making it about as fast as a dog, would have 3 kilojoules of kinetic energy. Recall that 10 kilojoules is needed to launch a 5-ton object into the air. What this shows is that Heracross can boost the power of Mega Horn by charging by as much as 25%. We can work out how far Heracross is capable of tossing something of this mass by using kinematics. At the moment of impact, we can use the fact that Heracross's horn would have a total energy of 13 kilojoules to calculate that it would be traveling at 72 meters per second, or just over 160 miles per hour. This value is enough for us to calculate the maximum distance Heracross can launch something with the mass of a blue whale. The object would be launched at a speed of roughly 2 meters per second, which I mentioned before. Using kinematics, this 5-ton object would travel about 50 centimeters horizontally if launched at a 45-degree angle, or around 25 centimeters straight up. This might not sound like much, but it would be enough to destroy the bones of an adult elephant, which can just about support its weight under everyday loads. If this were a Heracross being launched though, since the mass is 100 times less, this would result in a 10 times increase in the speed, but a 100 times increase in the range. 50 meters is half the length of a football pitch, by the way. A Heracross charging into the bouncy body of a Snorlax would feel different from the same attack on another Heracross with a rigid exoskeleton. The impulse is a measure of how much momentum is transferred to an object during an interaction. More simply, impulse tells us how much damage an impact would cause. For example, a Snorlax would cushion the impact by spreading out the force over a long time period. More technically, a Snorlax would cause the momentum of Heracross's Mega Horn to be transferred over a longer duration, lowering the perceived average force. Heracross's strength is staggering. Speaking of stags, Pinsir, being inspired by a stag beetle, is similar to Heracross in several ways. Comment below if you would want to see a video on Pinsir. To biologically make a 54 kilogram beetle feasible and able to smash tanks with a flick of its horn, every part of it must be optimized. Heracross should be equipped with a lightweight exoskeleton, powerful elastic muscles, and organ systems similar to a massive mammal. In reality, because of Galileo's square cube law, Heracross cannot get across the threshold of realistic biomechanics.